Okay, we're going to be talking about a rule for inverses of derivatives, or the derivative rule for inverses, I should say. So think about a function and what in the world its inverse is. Okay, so a function would have an inverse if we can reflect it across the line y equals x. And essentially what happens is you interchange x and y to find the inverse, and then you solve for y again. So that's part of what we're going to be doing in the example we're going to look at. But let's take a look at the rule. It says if f has an interval I as a domain, and f prime, the derivative, exists and is never 0 on I, so the derivative should not equal 0 anywhere on that interval, then f inverse is differentiable at every point on its domain. All right, I'm going to stop right there for a second. The derivative can't be 0 because if you think about it, you're interchanging x and y, things are flipping. You're going to end up with a scenario where you're going to divide by 0, and that can't happen. And that's primarily the reason why 0 should not be on that interval. But let's continue. All right. So we will say that f inverse is differentiable at every point on the domain, which is the range of the original function. But the value of f, or the value of the derivative of the inverse at a point b in the domain of f inverse, is the reciprocal of the value of f prime at the point where a equals f inverse of b. So they give us this formula, and it says here that the derivative of the inverse at some point b is equal to 1 over the derivative of the original function evaluated at the inverse of b. Okay, so that is what we're going to look at, but if it's confusing, it's okay, because in practice we'll see it. And what we'll do is we'll take a look first at how to find the function of the inverse, and then we'll do another example where we actually evaluate an inverse at a particular point. So let's go ahead and do that here on these examples. All right, so here's number 1. All right, first thing we know is that f of x equals 27x cubed. So first thing I think we should do, take the derivative. All right, and we'll see what we're going to deal with here. So we take the derivative, power rule derivative. It's very simple. All right, so whatever function you're working with, you apply the rules for that derivative. So take the derivative. We're going to power down 3 times 27. We get 81, and then we subtract 1. So 81x squared. So we're off to a good start. Okay, now what we need to do is we need to take a look at the original function again. Y, and remember, y is a function of x. So f of x is y. So y equal 27x cubed. And remember what I said earlier, we're going to have to interchange x and y. Okay, so we go ahead and do that. All right, and we're going to say then x equals 27y cubed. Okay, so what we're doing is we're trying to find the inverse, and this is a procedure that we're going to follow. Okay, so now what we're going to do is we're going to solve for y again. We're going to isolate y. So one of the first things to do is divide everything by 27. Divide everything by 27. That crosses out there. That eliminates. And so we are left with something that looks like this. Let me change my pen color real quick. Y cubed equals x divided by 27. And to solve for y in this case, well, we would take the cube root of both sides, but that's the same thing as raising it to the 1/3 power. So as long as what you do to one side, you do to the other, you're good. And so that gets rid of this exponent issue there for us. And we can say then that y equals, okay, x to the 1/3 over 27 to the 1/3, which if you know anything about this, you know that this is x to the 1/3 divided by 3 because the cube root of 27 is 3. So it looks something maybe like this. 1/3 x to the 1/3. Something like that. And this right here is actually f inverse, the inverse of the original function f. Now we're ready to piece everything together to find this quote-unquote derivative of the inverse. So it looks something like this, suppose. And I'm using square brackets there just to distinguish between the parentheses that's inside. But we want to find the derivative of the inverse. So in order to do this, we're going to say 1 over, all right, now f prime is the derivative. So we're going to have here the derivative, which was 81 x squared. So watch this. I'm going to put 81 parenthesis square. Okay. Now what goes inside? Well, let's reference back our formula. What goes inside? F inverse. Well, this right here was F inverse, and it's going to go plugged in right there. Okay. So it's going to go plugged in right there. So let's just erase this and let's plug it in, and I'll leave it in red. So 1/3 x to the 1/3. Okay. So you've got a power within a power, and you're just going to have to kind of evaluate that. And so let's see what that looks like. All right. We end up with 1 on the top in the numerator. In the bottom, in the denominator, we have 81. And then the 1/3 squared becomes 1/9. And then x gets raised now to the 2/3 because you multiply when you raise a power to a power. So now we are free to multiply this 81, distribute it in. 81 times 1 divided by 9 is 9. So we have 1 over 9 x to the 2/3 power. And this right here is our derivative of the inverse. All right, it's as simple as that. It's as simple as that. All right, it's maybe a little bit of time consuming work, but it is definitely very manageable. Okay, and it's there's a 2-step process here. Find the derivative, find the inverse, and then you take the reciprocal and you kind of just plug in the inverse into the derivative, and nothing to it. So pretty intuitive. I mean, when you think about it and really think about the process and why it works the way that it works, and I think you'll figure it out. Okay, so what we're going to do next is we're going to actually evaluate a function or an inverse function anyway at a particular point. So let's go ahead and pause real quick and we'll bring that out. Okay, so here's a problem that we're going to look at. We're going to find the inverse function, then we're going to evaluate at the number that they gave us, which is 4. Okay, so this one a little bit different, maybe a little more difficult because finding the inverse maybe not as easy, but we're going to get through it together. Okay, so again, first part of the process, let's find the derivative, f prime. All right, that part's easy. X squared minus 6x plus 1, derivative is 2x minus 6. A simple power rule that we apply. But now what we do, if we have y equal x squared minus 6x plus 1, we're going to interchange the x and the y. Okay, we're going to interchange the x and the y. Okay, so that's what's going to be a little bit interesting here. X will now equal y squared minus 6y plus 1. Okay, now to go about this process, solving for y, we're going to have to complete the square. Okay, there's going to be no escaping it. Okay, so what we're going to do is to complete the square, we're going to move this 1 over to the other side. That's the first step. X minus 1, and I'm going to put plus parenthesis square. This is all part of the completing the square process. So I'm going to also put it here, plus parenthesis square. Now what goes inside the parenthesis, you might ask? Well, it's half of your b coefficient. So it's half of this right here. All right. So we have that 6 there. All right. Half of that, which is going to be a -3. All right. On both sides. Okay. So let's see what we get when we do this. On the left-hand side, of course, we're going to have x minus 1 plus 9. And on the right, the whole purpose of this was to kind of do this thing that I call the completing the square trick. And that is that we've made a perfect square trinomial. And we actually, all we have to do is write out what that binomial square is, which is going to be y minus 3 quantity squared. So you pull in those two values, the y and the -3, and then you square it. And when if you're questioning, well, what in the world's going on there? Well, when you square this right here, when you square this here at the bottom, you end up with y squared minus 6y plus 9, which that's what this right here is actually equivalent to. Okay, so that's what's going on. They're actually equivalent statements, so there's nothing more to it. All right, if you need to, do your FOIL method, but you'll figure it out. Okay, you will figure it out. All right, so let's go ahead and continue. We end up with something that looks like this: x plus 8 equals y minus 3 quantity square. And again, we're solving for y. So what we're going to do is take the square root of both sides to get rid of that square. And we end up with the square root of x plus 8 plus 3 on the outside equals y. All right. And this right here is our f inverse, our inverse function. Okay, so we need that. All right, we really do need that. So remember, let's recall our, and let me not use Leibniz notation, I'll use prime notation. F inverse derivative is 1 over f prime, which is the derivative evaluated at the inverse that we were looking for, or that we just found rather. So there's our kind of guide, our formula, if you will. So we have enough information, and we're going to say that our inverse derivative is going to be 1 over, and I have 2x minus 6 is my derivative, so 2 parenthesis, and I'm going to make this a little bit large, minus 6, okay? And then what goes in this spot? Well, it's this inverse function here. So let's kind of draw a little directional arrow that's going to go plugged in there. Okay, and let's go ahead and plug it in now, which is the square root of x plus 8 plus 3 on the outside. All right, looks something like that. Not much to it other than some simplification, I think. Let's see here. We're going to distribute that 2, 1 over 2 square root of x plus 8 plus 6 minus 6. Well, those 6's end up canceling. All right. And we have our function. This right here is the derivative of the inverse. All right. Really nice. So now all we have to do is evaluate it at the value that they gave us, which was 4. And that's not too bad. Okay, so let's take that and say that we want to find, let me maybe move this up a little bit. We don't have to zoom that far out. All right, so let's say I want to find f inverse of 4, that's what we're looking for, prime. So that's 1 over 2 square root of 4 plus 8. All right. And when we simplify all of this, this is 1 over 2 square root of 12, which is 1 over 2 square root of 4 times the square root of 3, which is 1 over 2 times the square root of 3, which is 1 over 4 square root of 3. Looks something like that, okay? Now we can rationalize the denominator by multiplying the top and the bottom by the square root of 3. We end up with something like the square root of 3 over, this right here is 3, so 4 times 3 is 12. So the square root of 3 over 12, and this right here is our derivative of the inverse function evaluated at the value of x equals 4. And there's not much to it. All right, so this right here being our final answer if we're asked to evaluate an inverse or the derivative of the inverse at a particular point. Okay, so maybe a lot to sink in or to take in all at once, but you know, pause, rewind, fast forward, whatever you got to do to understand it, and hopefully it'll be helpful. And as always, like and subscribe.